Hello everyone. Thank you for attending this session on Supercharging Enterprise Multiclouds. It's a joint session between Red Hat and Juniper, and why that is the case we'll get into in this short introduction before we go into the meat of it, which is actually a demo of, guess what, Supercharged Enterprise Multiclouds. My name is Tore Smedman. I am heading up the strategic alliances and the partnerships in Juniper for our SDN business unit, and of course the main show for us there is Tungsten Fabric and Contrail Networking. And with me here I got a whole set of colleagues, and in particular I want to introduce Ali Kafel. He is my counterpart at Red Hat. We have been working a lot together over the last couple of years, and it's really a great company we have with our colleagues at Red Hat. We have been working for some time on product integrations with customers and in our labs, and we have worked with Red Hat OpenStack and with OpenShift in coming up with solutions to meet our customers' needs. And as we've been doing this, we have both developed our products. So we have developed Contrail, and Red Hat has developed in the community OpenStack and OpenShift as well. And now we're at the point where we need to find a way to bring all these technologies and possibilities together. So we got VMs, we got containers, we got a PaaS, we got networking, we got clouds, private clouds, we got public clouds, and of course we need to secure all that. So as we have been sitting down together and trying to figure all this out, we have sort of come to the conclusion that we need to do more than what we have been doing in order for what we're all doing in here with open source and open systems is going to be successful. And this morning we had a joint announcement of the first step on that journey, a joint announcement between Red Hat and Juniper on creating solutions and an initiative around making all these technologies simple and secure to consume and operate for our customers. So with that, I'll hand it over to you, Ali.
Thank you, Tore. Hi, I'm Ali Kafel. I'm with Red Hat. I'm Director of Business Development. I also handle the strategic alliance with Juniper. I've been working very closely with Tore and the rest of the Juniper team. And what I want to really emphasize, Tore mentioned Juniper and Red Hat have been working together for a while now, a couple of years longer, a couple of years actually even longer than that. But today, as Tore mentioned, we made an announcement, a joint announcement that really enhances the collaboration between the two companies. So what that really means, and that's what you will see today in the demo that the Juniper folks are going to show, is that today, today if you are using Red Hat OpenStack or OpenShift or both, you can now have a packaged solution with Contrail in it for networking as if it were one integrated solution. So what that does is it makes it much simpler for our customers, because in the past what you would have to do is get Red Hat OpenStack or Red Hat OpenShift, and then get Contrail, and then somebody would do the integration. Well, with this announcement, what we've done is made it simpler. So now essentially you got Contrail and OpenStack and OpenShift all packaged together as one offering. So it adds that simplicity, but also it adds, as Tore mentioned, additional security, because there are some policy and security capabilities that Contrail brings that really enhances the whole cloud security. So, and at the same time, you have an open solution. So you got simplicity, you got security, and you got open solution, because it's all based on open source software. So you can now have your cake and eat it as well. So you don't have to really go with a proprietary system. For the sake of simplicity, you can actually have open system that is simple, that is secure, that's more secure, and obviously well integrated together for simplicity. So with that, I'm going to turn it over to Shri. I think she's going to talk about the demo and show you the demo.
Thanks, Ali and Tore.
Thank you.
My name is Shri Sarva. I have Rudra with me. I'm part of the Contrail Solutions team, and Rudra runs engineering. I'll talk a little bit about multi-cloud, which is the topic of the session. Multi-cloud is no longer a strategy or a buzzword. It's a reality that most of the modern day enterprises are dealing with. And that's the focus of the demo today, on how we are embarking on this journey along with Red Hat together as an integrated solution offering. In today's demo, we will see an on-prem data center, a typical class fabric with a bunch of servers. We'll bootstrap and deploy a Red Hat ROS v13 Queens cluster along with Contrail, with the backend integration with Red Hat Director. And in the same environment, we'll also onboard a Red Hat OpenShift cluster, where we'll instantiate a couple of pods and show connectivity between the virtual machines and pods, which are working in a nested mode environment, all powered with Contrail being the networking layer. And then we will extend this infrastructure to a public cloud with a couple of clicks. I wouldn't say single click, probably 2 clicks. You'll see it extended to a public cloud. In today's session, we will focus on AWS. You can get the same experience with GCP or Azure or any public cloud of your choice, where we will deploy a couple of additional OpenShift slave nodes in an AWS VPC environment and show connectivity between the pods that are deployed in AWS VPC and the on-prem workloads, all being managed by Contrail, which is providing secure connectivity across the board. With that, let's get to the demo.
So how do we get into demo? Okay. Yeah. I think it started, right?
I'll start.
Okay. So hi everyone, my name is Rudra Roge. I'm part of Contrail Juniper team. And what you're seeing here is our new UI as part of Contrail, which is called Contrail Command. This UI is designed to handle right from cluster onboarding to fabric management, your instance onboarding, and complete day 2 operations of analytics and telemetry. So with that, we go in, and this is the dashboard that you land in, which gives you a complete overview of what's happening in the cluster. We've redesigned the UI to be able to go within a couple of clicks to any mega menu interface. And on the mega menu choices, we have infrastructure, which is where you have onboarding of servers, onboarding of clusters. Fabric is your data center network devices. Workloads, this is something that you've seen in Horizon, whether it's bare metal, virtual machines, containers, and so on. In addition to that, we have security, services for NFV or service chaining functionality, virtual networks, and so on. So as we move forward, the first thing in a data center that you want to get a view of is your network device or your class fabric. And there's a whole bunch of functionality that we've added as part of Contrail Fabric. One of the key things are discovering devices that are in your fabric, displaying your class topology, adding devices, assigning roles, and so on. Based on this, you have set up and onboarded everything in your Contrail cluster. And now the next step is to actually provision a Red Hat OpenStack cluster. So we'll jump into that. The first step of creating this is to onboard servers that are required for your control components as well as your compute nodes. So here we'll see that we can import a CSV file with a list of servers and add it in our wizard as the list of servers. There are different roles for each of these servers. The next step is to create a Red Hat cluster. We are using containers to deploy this cluster. You have containers from Red Hat, containers from Contrail, and all these containers are hosted at hub.juniper.net. We'll bring in the right Contrail version. Ansible is our default form of deployment, default provisioning deployment tool. You need to set up the basic configuration of NTP server and default gateway. And the next step for this is to add a list of control data networks that are needed for the server. So we'll go through those steps.
Once we do that, the next aspect of this wizard is to be able to add control nodes. And this is a simple onboarding. We've already imported the servers. It's a matter of just assigning the right roles for control components, for Contrail components, and for OpenStack nodes. And the next step is for Nova Compute and Contrail vRouter functionality to come in, and that's through the compute node installation. Once you go through this whole process, you have a full summary of what you're trying to configure or what you're trying to create with a Red Hat cluster. And once we click provision, in the backend, we have Ansible runs going and provisioning both Contrail and Red Hat. And you can see once the overcloud provisioning is complete, we move to the next step of installing and running our compute nodes.
Right. So now the Red Hat ROSP cluster from the topology is onboarded in your on-prem data center. We log into the cluster and we do the usual thing of creating a virtual network, attaching a subnet, launching a workload. Right? Yeah. So let's go ahead and create a virtual network called VN1 and attach a subnet called 192.168.10.0/24. That's the VM that just got created, and that's the subnet that we are attaching in this on-prem ROSP 13 plus Contrail cluster that we just deployed. The cluster installation takes about 10 to 15 minutes based on where the containers are hosted and how long it takes for the containers to be downloaded. Now we are booting a virtual machine here, a Ceros VM in VN1. And this has an IP address of 192.168.10.3. Now what we will do is, as part of the same on-prem infrastructure, we also have a Red Hat OpenShift 3.9 cluster deployed, which is pointing to the same Contrail controller. So the same Contrail controller is managing both OpenStack as well as the OpenShift cluster, which is deployed in a nested mode. We'll launch a pod, BusyBox pod in the OpenShift cluster and have it point to the same virtual network as where your virtual machine was instantiated. For this, what we do is we have introduced a custom annotation in the YAML file. You'll see that in a second, where you define the networking annotation to point to OpenContrail with VN1 being the network where you want to deploy this pod. If you see the highlighted text, it says that it's using OpenContrail for networking and we want to launch this BusyBox pod in VN1. Okay. So let's log into the BusyBox pod and see the IP address that it gets. It will be part of the same subnet where we have instantiated the virtual machine, and there you go. So it's 192.168.10.4, where we have instantiated a pod container within an OpenShift environment, which is also managed by the same Contrail controller. Now let's do a quick ping test to make sure that they can actually talk to each other. Okay, so that it shows that the OpenShift cluster where we have instantiated the pod, BusyBox pod, can talk to the virtual machine which is sitting in the same infrastructure. Now let's extend this infrastructure which is on-prem to public cloud. In this demo, we are doing AWS as an example, but you can do the same thing with any other public cloud. There's nothing that's sitting in the AWS VPC. We go back to Contrail Command and go to the ROSP 13 cluster and say extend this cluster to public cloud now. And that's pretty much, like I said, it's 2 clicks away where we add the subcluster saying that ROSP 13 now extends to AWS VPC with so-and-so credentials. We populate the form and say add, and that results in spinning up the required infrastructure based on the subnets, VPCs that you have defined in the form, In the back end, it actually runs a Terraform template where it deploys and provisions a on-prem gateway and a public cloud gateway, providing secure connectivity between your on-prem and the public cloud instances. There you see now we have a bunch of EC2 instances that are created. One of them is the gateway that sits in AWS VPC, and there's an on-prem gateway that is also deployed. Now, if you see the gateway IP address, it's 172.16.0.47. That's the IP address of the slave, OpenShift slave node that is deployed as part of this public cloud extension. Now, let's log into the virtual machine that we have just created in the ROS-P13 cluster and instantiate another pod in the public cloud EC2 instance where there's a OpenShift slave node that we have just extended. So, you can fast
forward.
So, let's log into the metadata IP for the VM. Again, this is we are deploying a web app pod on the OpenShift slave node, which is running in your AWS EC2 instance, and we are using the same networking annotation as we did in the on-prem pod. Now, the pod has been just created. We'll log into the pod and show connectivity of the application that you have just deployed in your public cloud environment with a virtual machine that is actually sitting on-prem, and you can see the communication that's happening on the secure gateway that is instantiated as part of extending your on-prem infrastructure to public cloud. Let's do a quick ping test to make sure that, so that's the TCP dump we are actually doing on the gateway node that gets instantiated as part of the public cloud extension. That's the IP. The IP address is 192.168.10.3 of the on-prem VM, and you can see that the pod that's deployed on the public cloud can now talk to your virtual machine that has been instantiated in the on-prem data center that we have just created, and you can see that it's a secure port 443, which is a SSL traffic that is being that you see transit between your on-prem and public cloud infrastructure. The cool thing about this is that you don't have to put any of your infrastructure in a DMZ zone or touch your network devices to punch holes, so on and so forth. It's cloud native way of extending an existing cloud infrastructure to public cloud needs. That way you can address cloud bursting needs or federation of multiple instances of clusters that you have across the board. So in this example we showed public cloud. It can be yet another site that you're managing and you just want uniform network connectivity and security posture across the board. So let's log into the Contrail Command UI and see the topology that we have just created. This is just verification that we are able to manage to ping across both the on-prem and public cloud. Let's log into Contrail Command and see a topology view of the ROS-P13 cluster that we have just deployed. And here you see that ROS-P13 cluster has a bunch of compute nodes, ROS-P controller, a Contrail controller node, and a public cloud extension that you see over the WAN using Contrail vRouter as a secure gateway, where you have rest of your OpenShift slave nodes that are being deployed. So in summary, we are extremely happy to partner with Red Hat to deliver this multi-cloud story, and it's time to supercharge your multi-cloud with us. Thank you.